The final thing we need to do on our form is get our spinner, our drop-down, working. And the good news is it's actually super easy and quite similar to something we've done before. So if you think of your spinner, your drop-down, I'll just show you in activity_main. So you have the little arrow, and then you have some contents. And the best way to think of spinners and how they work is much like a list. So we've already used a list view, a basic widget for adding an array of things, whether that's strings or objects. You give it an adapter, and then the list view takes care of the rest. Well, the spinner works in much the same way. So if you think of the spinner like a list, we just need to make an adapter, give it an array of things, and the spinner will take care of the rest. So let's jump back over to main activity. And after where we're doing the button preview click listener, make some line breaks, and we will make a new adapter here. So just like when we did the list view, we don't need to do any complicated recycle view adapter with extending classes and view holders. We can use that simple, ready-to-use array adapter, just like we did for the list view. So we'll make a new adapter variable, we'll do val, because we're not going to change it later, and we'll call it our spinner adapter. And we'll make that equal to a new array adapter. We'll be getting onto classes in Kotlin very soon, but just as a quick reminder, when you make a new object, you don't need the word new in Kotlin, so we'll just do the class. So with a capital A, array adapter, just like that. And you can see we've got the diamond bracket with the type inside, so we could do this, we could put string there, because we'll be putting strings inside this array adapter. But you can see in just a moment that Kotlin is going to be able to infer the type. Because we're going to be giving it an array of strings, it will know that it contains strings, so we don't actually need this. The wonderful benefit of Kotlin type inference, a bit like our variables, okay? So do the normal brackets, and we can see it needs 2 or 3 things. It needs a context, so we'll say this for this screen, and then it needs a layout. And we can use one of those template default layouts, so we'll do Android, so one of Android layouts, .r.layout. And then there's plenty to choose from, and the one you want to do is simple underscore spinner underscore drop down item. That's the one we'll use. That will give us a very simple but well formatted, well spaced with nice margin or padding, a nice drop down layout for our options. And the last thing it needs is the array of strings. So I'm just going to leave this for a moment. I'm going to press escape. So that's going to be an error for now, but that's okay. Now the way that we declare array variables in Kotlin works a bit different to Java, and also that array initializer block that we've used before in Java doesn't quite work like that in Kotlin. So I will show you these differences here and now. A couple of small changes, but I don't think it warrants a completely separate tutorial. So we'll cover this now. So above the spinner adapter, let's make a new variable, and we'll call it our spinner values. So if I just show you what the variable type looks like now, we'll do a colon. So you might think we can just do, like Java, string array. But this syntax isn't recognised in Kotlin. So the Kotlin equivalent would actually be the word array with capital A, and then our diamond brackets to specify the type. Now personally I prefer this. We so rarely use those square brackets in Java, and for a new person coming into the code it would be difficult to know immediately that those square brackets do mean an array. Whereas here in Kotlin we explicitly say the word array, and we use those diamond type brackets that we do see quite often in both Java and Kotlin, these diamond type brackets. Okay, so that would be the equivalent of doing string array like that. And then for the array initializer block we will just do those curly brackets and start doing our strings like that, separated with commas. But again, this isn't recognised in Kotlin. The equivalent would actually be a very useful Kotlin method, a Kotlin function called array of. And then inside these curly brackets, our, comma, array, comma, values. Okay, so 2 changes there. To declare a variable, which is an array, we say the word array and then the diamond type brackets. Although we can actually remove this now, because Kotlin can infer that we have an array here, and it can see that inside it is strings, so it knows that's an array of type string. And the array initializer block, rather than just doing curly brackets, we have the function array of, and then we pass in our values. And again, I also prefer this because I'm used to these curly brackets being class blocks or on-click listener blocks, things like that. It's not very descriptive just seeing curly brackets for an array initializer, but when you see the word array of, and then the values, to me that reads really clearly. Somebody coming into a project from a different language who doesn't know Kotlin would be able to look at this and see what's going on. So now we can pass in spinner values there, and that is our spinner adapter done. What I will do for the purpose of this tutorial is I will actually leave the array and then the type string in. Even though Kotlin can infer this, it will probably be really good for you, for your reference code, to see how arrays work in Kotlin. For educational purposes, I'm going to leave this in if you want to do the same. So we have the spinner values, we pass them into our adapter, and the last thing to do is to set it on the adapter. So I'll do spinner job title. From our Kotlin extensions, we can just use the view ID, and then it's adapter. Spinner job title adapter equals the spinner adapter, and that is all we need to do. Remember, in our onPreviewClick function, where it says job title, we're doing spinner job title dot selected item, could be null, so then we do dot toString. Because actually, in our array adapter, we can pass in any type. We could pass in project, dishes, okay? But because we're doing toString, it will get the string version of that. And in the case of our string array, it will just literally be the string as we typed it. So these 3 lines here are all we need to do to add values to our dropdown, to our spinner. Create the array of values, make our simple array adapter, giving it a layout and values, and then set adapter on the spinner. And then we retrieve that value with the property spinner.selected item. Okay? So let's change our array values to the ones we want to use in our project. So we'll have the option of being called an Android developer, or we'll have the option of being called an Android engineer. That's the 2 most common ways of introducing ourselves. I'll remove that value. So let's now go ahead and run this and see our new spinner values. So you can see there we have Android developer, our first value in our array. And when we click that, you can also select Android engineer. So let's quickly fill out the form. Salesperson. I'll say I'm a junior Android engineer with an immediate start date and preview message. And there you can see on our message preview we now have job title Android engineer. So that is spinners in Android and arrays in Kotlin. It's time for another Kotlin Foundations tutorial, this time on classes and objects in Kotlin. I'm in a new Scratch file under the Kotlin Foundations folder, which I've renamed to classes and objects. If you can go ahead and do the same, and then I'm going to close down the project pane for the rest of the tutorial. So we'll start off first of all with a basic class in Kotlin. So just like Java, it starts with the word class in lowercase, and then the name of our class, starting with a capital letter. So we'll call this a Kotlin and then class, like that. And then our curly braces. Always start your classes with a capital letter, and then a capital letter for each word, upper camel case as that's known. Okay? And what we'll do is a nullable string. And of course we need to initialize that, so we'll initialize that to null. So we have one class property, a variable, and then we'll do a function. So fun, a class function, no parameters, and we'll just do something simple like print line. I'm a tool that's different to Java, apart from the way we do our variables and functions. The class itself looks very, very similar. So let's make a note at the very top. We'll do triple do Java. Okay? So now let's make some objects from this class. Let's make some new instances of this section. We don't, let's say, in Kotlin, we don't need the what works okay. So we will do class test dot a class property, and we'll set this to something like setting the class property. And then we'll call our one function, our one method, a classes. So we move now onto one of the first major benefits to the way that Kotlin does classes, and that's in the way they do their constructors. So if you can go ahead and put that new heading If we think back to Java, we would define our class a bit like we've done at the top here, and then the constructor would look a little bit like a method. It would be its own block inside, starting with the name of the class. It would have parameters, and then typically we would pass in all the variables we needed and then set them with this.variable equals variable, this.name equals name. Okay, quite a long, cumbersome, time-consuming process. Well, in Kotlin, the constructor immediately follows the class name, and adding val or var makes the value a class property or variable. So if that sounds confusing, let me immediately show you what I mean. We'll make a new class now, so type the word class, and let's call this class with constructor. So now, inside these brackets, you can put the class properties, the class variables, directly. So let's give this class a property right now. So we'll give it a variable, something we can change. We'll do var, and then we'll call it a class property, and we'll make it of type string. And believe it or not, right there inside these brackets is both a constructor and defining the property. What I'll do to really make this example clear is I'll do a few more properties, a few more values inside this constructor, and I'll show you this in just a moment. Let's also, I'm just going to scroll across and make this of type int property private, a class. So I know this is quite a long line here, but in that one line, we're doing both the constructor and the properties. So in terms of properties, putting these variables inside these brackets, inside this constructor, is the same as doing this. Those variables. So these 4 variables here create properties just like this. So it has the effect of creating properties just like below. Okay, so let's cover a couple of other things here. You notice that most of our properties are non-nullable. Now if we scroll up to the very top, we made a nullable class property here, and we had to assign it to null. We couldn't do this. Error says must be initialized, okay? But because all of these properties are inside the constructor, well, it's not possible to make this class without having these values. So because of this, because we are demanding these properties in the constructor, it's possible to have non-null properties like this, okay? So using the Kotlin constructor is very powerful for multiple reasons. If you want to make them nullable, no problem, add a question mark, okay? So let's make another note to say exactly this. Because we demand these values in the constructor, the properties can be non-null. And just one final note, we can choose var or val if you want a variable or a fixed value, and we can state access modifiers. For example, private, and we'll just put in brackets. They're all public by default, as we learned previously. So a few things to note there, but this Kotlin constructor is incredibly powerful. Let's now play with our new class underneath. So we'll make a new val, because we're not going to change it. We'll call it our constructor test. And that equals a new object. We don't have to say the word new. I'll just say this could be null. Then we have a fixed property, which is a number, so I'll make it a number 7. My lucky number. Everybody's lucky number. Okay, and then the final one is a secret property, the private one. So let's just call this shush, comma, it's secret, exclamation mark. So we're making a new object, and we're calling its constructor, which in Kotlin is in line next to the class name. And in doing so, not only do we set the parameters, the values of our constructor, we also can define the class properties right there in one place. No more duplication, no more this.name equals name, this.age equals age, okay? Much, much shorter, much, much easier, and in my opinion, much, much clearer. So let's now do a toString method on our class with the constructor so that we can see what all the properties are set as, a bit like in our class function one above. So let's override the toString method. Just like in Java, every class can override a default toString method. So if you start typing lowercase t, 2 and then string, super.toString, we'll delete the parent class default behavior, and we'll just return an empty string for now, okay? So if we look now, the override is in line. Before, it used to be over the top like that, yeah? But that involves an extra line. A quick note about that, or toString for this class. Let's say the name of the class, then some brackets, and then let's just say what all the properties are equal to. So we'll do class with constructor. So we're going to show what the class is, and do some normal brackets like that. And then we'll do something like the name of the property, then an equals, and then we'll use our wonderful Kotlin string template, so $, and then we can put the property value in line like that. So we'll do that for each property, separated by commas, so a nullable property equals a nullable property, comma. So that's the string method by doing a print line on our new object. And we could do constructor test.toString, we could do that, but actually the toString is superfluous. We can just do the object because it will automatically call the toString. So when we do this, if you look to the right on line 38, class with constructor, then you have the property equals, and then whatever value you set it to. If I just drag this across a little bit. Okay, so that's cool. So to show you these different properties we have at the top here, including a warning, which we'll get rid of in a moment. So our first property was a regular var, a class property, so we can change that. So let's do our constructor test object dot a class property, and we'll change that to something else. I'll make it my full name, Vincent Norman. Okay. Now we did make the first property nullable. As you can see up there, it's string, not string with a question mark. So if I try and do constructor test dot a class property equals null, well, we have the error telling us that we can't make null a value of a non-null string type. So we'll comment that out. We'll just say can't make this null. This property is not null. Then we can make this null, and that's absolutely fine. Then if I actually just quickly look up, we had our fixed property. Now, if I hover over this, it's saying this could be private. So Android Studio can see that we haven't called this one anywhere outside the class, so it's suggesting it could be private. But when I access it here, constructor test.afixed property, when I call it just to see what the value is, which is 7, then you can see that warning goes away. If I then try to change it to something like 12, it says val cannot be reassigned, because in our constructor, we set this variable to be val. So this should all be recap of our knowledge of variables. So we'll comment this out, and we'll say, okay. And the final variable we had, if I scroll up, was our secret property. But a secret property, if I try and even access it, we get a warning that says we can't access it, it is private in the class. A bit of recap there about our variables, nullable versus non-nullable, var versus val, and also our access modifiers for having the word private, okay? But hopefully you're seeing that in this constructor, we are also defining the class properties, and we can do anything we want with them, just like if we defined them here. There's just one final very quick basic thing I want to show you before we leave classes for now, and that is a new type of class that Kotlin calls a data class. So make a new heading, 3 stars, and we'll say data classes. If we think back to our project class or our dish class that we made in previous sections, they weren't really doing anything that complicated. They weren't calculating a BMI or doing anything advanced. They're pretty much just holding values for us, a data container. So if this is the case in our code, then we can use Kotlin's special data class. So let's go ahead now underneath this and type the word data and then class. And I'll just call this with a capital F, of course, my data container. And we'll do a constructor. In fact, you have to do a constructor with a data class, so normal brackets, and then we'll just set a few standard variables. We'll make them all vals, so val, some data, we'll make it a string, we'll do some more, which will make it a boolean, and then yet more, and that could be an int. Okay? Now you may be thinking, well, what's the difference? And the short answer is not much. It's still a normal regular class. We could just do this without the data word. Okay? However, it does a couple of things under the hood, gives you some extra behavior, one of which we're going to see in just a moment, which does make it quite useful for inspecting our objects, for looking at our data classes and seeing what's inside them. So let's just make a quick couple of notes under this heading. Let's say we can use a data class if our class mainly just holds values, and we just add the word data in front of the word class. This comes with a few benefits, which we can see in just a second, one of which is a useful descriptive toString method. So if I scroll down, I'm not even going to give this data class curly brackets. We don't need to. There's no contents. Because we've annotated this with the word data, it has some default behavior for some of these methods already. So to show you this, without doing anything else, I'm going to those values in the constructor. I can now do print line and pass in this new object, just like that. And let's see what the output is. I'll just scroll this across a bit. Go to the very bottom. The name of the class, my data container, and then brackets, and each of our properties and the value that is set. So pretty much, if I just scroll up, all that we did previously, if I show you in the code, we had to do it with this big long line here. Okay? So if I just scroll back down again, if you annotate a class as data, you get some useful benefits like this, one of which is a very useful toString method. Okay? I recommend if you're creating a class just to hold data, always annotate it with the word data. Define all the values you need in the constructor, and then it becomes a very short, simple class that just acts as a container for your values. Okay? And we'll get a chance in just a moment to apply this in our project when we look at finding a better way to pass data from screen to screen. Okay? So, basic classes, constructors, and data classes in Kotlin.